There are tons of videos you can find on YouTube that use computer automation to beat a lot of different games. One of the biggest names in the YouTube coding community, CodeBullet, has used Python to beat a wide variety of games from everything from Flappy Bird to Minesweeper. If you just search using image recognition to beat, you can find an even wider variety of games by different creators, all passionate about different games. And I think they're just a bunch of really cool projects. However, as a lifelong Nintendo fan, one video captured my imagination for the longest time, and that was Noodle's video using image recognition to find Mario. I loved playing that minigame as a kid, and his explanation of recognizing new challenges and overcoming them is, in my opinion, a masterclass in learning how to problem solve. That said, I watched a lot of his series, especially the ones dealing with image recognition, and while I loved them, I felt like there was a perfect application not covered by him nor anyone else that I could find.
Nintendo!
You saw the thumbnail. I'm obviously talking about Mario and Luigi Bowser's Inside Story, which, as a tangent, is easily one of my favorite games of all time. The visuals are great, the gameplay is great, the music is phenomenal, and the most outstanding thing about it to 8-year-old me was that you got to play as freaking Bowser. Getting to play as Bowser was so cool, and while the Bros gameplay is also very fun, every time I played as them, I was always thinking in the back of my head, when do I get to be Bowser again? Speaking of, if you're playing as the titular turtle and wander over to Blubble Lake, you'll find Broke Madame. This serves as a minigame collection for Bowser, testing some of his special attacks to see how long of a streak you can build. With 3 strikes and you're out. My goal is to get at least an A rank for all 4 attacks. This includes Goomba Storm, Koopa Core, Magic Koopa Mob, and Bob-Omb Blitz. I started with Goomba Storm, in my opinion, the most iconic and recognizable attack from the game. For this attack, Goombas charge from the left side of the screen, and you need to click them before they reach Broke Madame. If you do, Bowser shoots a fireball at them to turn them into a meteor. If you don't click them, they run harmlessly into Broke Madame, and you receive a strike. Miss 3 times, and the game ends, with all your successful Goombas raining down like arrows from that scene in 300. The other reason why I started with this minigame is that I thought it would be the simplest to automate. After all you have to do is see a Goomba and click it, and the others involve dragging your stylus. However, there is one thing that made Goomba Storm significantly more complicated to get started than the other minigames. I've never actually worked with any sort of computer vision project before. I know, shame on me, I specialized in machine learning in my undergrad, but I heavily favored and focused on working with tabular data. I never took a class dealing with this. How do you actually get your computer to see anything? Well, part of it is pretty simple conceptually. We have to give our computer eyes by adding visual input. In other applications, this could mean adding an external camera, but for us, I'll just have to add some code that takes screenshots of the gameplay. Think of this image as a haystack that we'll have to find a needle in. Subsequently, we'll have to provide a needle image of what we're looking for within the haystack. In this case, we want the face of a Goomba during its running animation. I thought we might need several reference images, though to this point, I've only needed one. Note, I did end up using half a Goomba face for my actual needle image rather than a full image. The full Goomba image just wasn't working very well, and full disclosure, throughout this project, I did lean into making the project work over having a perfect understanding of why. Quite honestly, it could have been a couple of different things, but once I got a working image, I stopped checking. For the actual code to grab the screenshots, I use the same module that CodeNoodles did, which is PyAutoGUI. It does a lot of stuff. We'll talk more about it later. But the actual code of getting the screenshot, once you have that imported, is pretty simple. You just need to have an XY coordinate and then the width and height of the area you're taking a screenshot of. For us, obviously, that's the area that the Goombas are running through. I'll talk a little bit more about some stuff going on here, like the scale factor, a little bit later. But it's pretty simple. I also want to take a minute to shout out Spriter's Resource. It's where I got my needle image from for at least this instance. So now we have the image we're looking for and the haystack that it's hiding in. It's still a little unclear how the computer can, quote, see. It might sound weird, especially for younger viewers who've grown up around facial recognition technology, but computers aren't actually good at pattern recognition. It's something humans are significantly better at. However, computers are very good at math, and they are very, very fast. A heavily simplified explanation of how image recognition works is that computer images are an array of pixels, and each pixel is represented by a color, a hexadecimal value. So we place our needle image in the upper left corner of our haystack and compare the difference in value of all pixels that our needle is currently covering. Then we move the needle image one pixel over and we repeat the process till we move it through all the possible positions it could be in. The area that is the least different when we compare these pixel values is determined to be the match. In our case, we'll actually need to find multiple images sometimes, so rather than just picking the least different, we'll identify everything that's within a certain threshold as a match. Again, this was a heavily simplified explanation. I'd recommend watching How Machines Find Patterns by Jiabin Huang, sorry if I butchered your name, to get a better understanding. I decided to use a different module than CodeNoodles in this instance, as I expected my program to need to be more heavily optimized for speed than his. My research showed that OpenCV's match template was going to be the fastest thing I could use, so I used it instead of PyAutoGUI's locate. However, as I was writing the script, I found that locate ends up using OpenCV under the hood, so I was probably splitting hairs. We end up also converting the images to grayscale, which also makes the computations a little bit faster. So we pass our haystack image, our needle image, and the comparison method we want to use into match template, which is this bit here. You can see template might be a little confusing. I changed the wording later to be needle and haystack, but template is going to be our noodle. See how we're getting it from our Goomba sprite. And then this image gray is the haystack. And then this third argument I'm passing in, that just specifies what type of comparison we're doing. I would recommend looking into this in OpenCV's documentation. I want to take a quick second to mention why the scale factor is in place. For this type of template matching to work, the images need to be the same size and orientation, or at least very close. The needle image is in the size of the original sprite, but the haystack is much bigger due to the size of my super special Nintendo DS. You can figure out the scale factor you need with simple math. If your needle is in the size of the DS sprite, then your haystack needs to have a corresponding ratio to the DS. The DS aspect ratio is 256 by 192. You just need to divide your width/height by the original ratio. The easier thing to do, which I do later on, if not for this, but maybe for some of the other games, is just take screenshots in the application, so they're already at the same scale. Alright, now I'm going to go ahead and give you a quick walkthrough of a little bit more of what's going on here. This was my initial commit, this was my initial branch, and full disclosure, I wanted to preserve the entire history of the project to the best of my ability so I could show you all the hurdles that I ran into. This first attempt, this was just my first time playing around, so I just wanted to see how well I could recognize these images. So this is just setting up the bounds of my screen. This X is the sub screen references the bottom screen of your DS. So this is its X coordinate, this is the Y coordinate, this is the width and height, and then this is the scale factor we were just talking about. This might not be the best way of changing the or implementing this, but I have an array that I'll put all my potential Goomba sprites in. I thought I might need multiple, and maybe at some point I will, because the Goombas do have a couple of sprites that they cycle through. I'm going to gloss over a lot of the rest of this. This is either code that I've already mentioned, or like local to global position isn't something we're going to care about right now. What we do is we get our haystack, we're getting our needle, and we're passing them into match template. We have our haystack, we have our needle, and we have this low short for locations. This is just going to be a list, maybe technically like a tuple with a list in it, where it's the location of all the Goombas that we identified. So for each of those locations, we're going to draw a rectangle around the Goomba into the image and then save that image. And as you can see, here is the result. We currently are able to identify the Goomba. Obviously, what we're not doing yet is we're not playing the next thing to do is add clicks, which is pretty simple. I added a method, press icon, which just takes the location of the Goomba with an XY width and height. The position is relative to where it is within our screenshot, which was reduced by the scale factor, so we have to scale and offset appropriately. Then we can use pie_auto_GUI to move the mouse to the position as well as click. I used drag at first since I wasn't sure if just clicking it will register. The running theme throughout the project is determining how fast we can do a click-like action without confusing the DS software. Now, I'm just going to quickly show what it looks like when we run the program. Awesome. We've now been able to find a Goomba in the running area and click it. Now let's just see if we can't loop over this code while the Goombas are actually running. These changes are pretty simple. Let's see how it runs. Okay, so we're obviously having an issue there, but I think in this case it's actually a pretty simple fix. Goombas are running the whole time, so after we identify where they're at, for the time it took to find them and then move the mouse and click them, they've already moved. So I went ahead and I just added a simple offset to the Goomba's X position. Let's see how this changes things. Awesome! My code is now able to play the game, and it's doing a pretty good job of recognizing the Goombas. However, we're nowhere near getting an A rank yet, and the general problem is pretty obvious. The program is just too slow. The question remains, what can we do to make it faster? To keep this video from getting too bloated, I won't show every run or do a video walkthrough of all of my code. Instead, I'm just going to kind of walk you through my process. My first thought was clicking right to left. Sorting the points should take a negligible time, and that way we prioritize clicking the Goombas that are the closest to hitting Broke Madame. I toyed around with the idea of multi-threading / multiprocessing, but honestly, it was probably not going to even really save me any time and be a lot of trouble. I switched my display layout to be vertical as opposed to horizontal. This was largely just because it was more satisfying for me to watch when I was testing it. However, it did come with the bonus of reducing the search space. This led to another idea. Why am I taking a screenshot of the entire bottom screen? The Goombas are only going to run through a portion of it. The smaller we get the screenshot, the less area we have to search. Similarly, I started reducing the drag time, finding it was still recognized as a click if held for more than 0.1 seconds. With these two changes, I increased the score up to 123. That's a significant improvement, however, it's still not where I wanted it to be. I was only clicking one Goomba per screenshot, and I started thinking, maybe I should try to click all the Goombas I find in a screenshot. This will save on the time it takes me to take screenshots. However, a quote my system's one professor loved occurred to me. If you don't measure, you don't know, and if you don't profile, you don't know where. What that means is, I should actually measure how long these actions take. Well, I forget what the actual times were, and I deleted the code that I used to measure it. The code clicking was spending magnitudes more time than the time it took to screenshot and identify the Goombas. So I kept reading the pie_auto_GUI documentation. At this point, I had already started working on the other minigames that were forcing me to find more performance as well. Not only did I adjust to start using the mouse down and up instead of drag, but I also realized that by default, these operations have a built-in pause timer that you have to set to false with an argument. So yeah, as a PSA, make sure you read your documentation. It will save you a lot of headache. With all that said, let's run the current version and see if we can get an A rank. have it. This video was run off of main. At this point, I'm just clicking the rightmost Goomba per screenshot and doing a mouse up and down that both pass false for the pause. But I do add a manual sleep in between the mouse down and up. There is a Pi Auto GUI property called pause that I left alone. I'll cover it more in a later video that actually changes that property. I'll add, my written high score in the code is 399. I don't know if that was a fluke or if at some point I made a change that negatively impacted the score that I forgot about. Cards on the table, despite my attempts at organization, I'm still a little scatterbrained on the project. I also think that even this version could be greatly improved. It's hard to tell in the video since I recorded at a reduced quality, but the mouse kind of spasms around the Goomba it's clicking, like it's trying to click multiple Goombas or something. A link to my GitHub is in the description for anyone who would want to push the performance. I also want to ask if anyone has any games they think would be fun to be with code. I've already done all of Bowser's moves, and I'm starting to work on the bros. I'm thinking maybe I'll do the gut check minigame, but after that, I'm open to ideas. I'm thinking about maybe doing the Pokeathlon Dome, but again, open to if people have suggestions. Link is in the description for the resources that I used and the videos that inspired me. Again, a huge shout out to Code Noodles. I wouldn't have made this video without his. And thanks again for watching. Let me know what you guys thought. This was really fun to make.